Hello, today I wanted to do a video trying to make sense of the Maxwell equations. And I wanted to start with the first one that we learned, which is Gauss's theorem for electricity, which was actually first derived by Lagrange. So it should be Lagrange's equation, but technically Gauss came up with it independently, so, what can you do? So, what it states is that the double integral of an enclosed surface of the E field dotted with the area is equal to the sum of charges inside divided by epsilon zero, or the permittivity of free space. Now, if you have taken Calc 3, you'll recognize that the double integral of a vector field dotted with an area is also known as flux. And so what this is really saying is that if you have this enclosed shape indicated by this circle, so I've got a sphere, it could be any enclosed shape though, and it's the flux of the E field through the area of that enclosed shape, that will equal whatever the charge inside is divided by E0. And to logically understand this, it's important to kind of draw a picture and think about it this way. So you'll notice I have a charge that's enclosed. That's what the ENC stands for. So Q1 is enclosed in this closed surface. And so you'll notice that the field lines are going out of the surface. And every time we have a field line going from the inside of an enclosed shape to the outside, we call that a positive flux. So you'll notice that this positive charge is making a field line that's going out of the surface. So if we go around and count, that's 1, 2, 3, 4 fluxes, lines that are penetrating the surface of the sphere. And that's a charge enclosed. Now if we look at a charge that's not enclosed, like Q2 for example, which I'm also treating as a positive charge, but I drew it in blue so that it would stick out more, you'll notice that any field line that it happens to emit is going to go into the surface and then back out of the surface. And when we have a field line going into a surface, that's negative flux. And likewise, when we have a field line going out of a surface, that's positive flux. So you'll notice that Q2's negative flux with its positive flux is going to cancel. And so the charge that's outside of the enclosed surface does not matter to the overall flux going through the surface. And so that makes a very useful equation. That's why we only care about the sum of charges that are enclosed in the shape. Alright, so that is Gauss's law for electricity, and we'll be going over a cool way to derive some functions using this equation.